Welcome to Integrated Math 1, and our topic for today will be graphing linear equations using slope-intercept form. We're going to be using a series of steps to graph linear equations in slope-intercept form. So the very first step is you can only graph these linear equations if they are in slope-intercept form. So slope-intercept form looks like this. Y equals mx plus b, where the y variable is on the left-hand side, and you have the slope and the y-intercept on the right-hand side of the equal sign. Now, m is going to be a coefficient in front of your x variable, and it's going to tell us the rise and run of our linear equation. Our b value is going to be the y-intercept in the form of 0, b. So we're going to be using the b value to find our y-intercept. Step 2, we want to graph the y-intercept. So the y-intercept is always going to be in the form of 0, b. If your linear equation is in slope-intercept form of y equals mx plus b, if you can identify your b, you can create a y-intercept in the form of 0, b. Next, we want to use the slope rise over run to create more points. We're going to be identifying the m. Now that is the coefficient in front of the x variable to find our rise and run. Alright, for our first example, we're going to graph the linear equation. So we have the equation y equals 2 over 5x plus 2. You first have to ask yourself, is it in standard form or slope-intercept form? Well, y equals 2 over 5x plus 2 has the y variable to the left-hand side of the equal sign. We have our slope, and we have our b value. So y equals 2 over 5x plus 2 is in slope-intercept form. Slope-intercept form tells me two things, my slope and my y-intercept. So I'm looking at 2 over 5x, and this 2 over 5 is my slope. So we have m equals 2 over 5. That's my slope. And 2 over 5 tells me that I'm going to have a rise of 2 units and a run of 5. Next, my b value is going to be 2. And my b value tells me my y-intercept, because if I have an equation in slope-intercept form, my y-intercept is going to be in the form of 0, b. So my y-intercept is going to be 0, 2. Now that I know my slope is 2 over 5 and my y-intercept is 0, 2, I'm going to go ahead and create my coordinate plane. So here I have my y-axis, here I have my x-axis, and my y-intercept of 0, 2 is going to be my starting points. So at 0, 2, I'm starting at the origin and going up 2 units. So right here I have my y-intercept of 0, 2. And my slope tells me that I'm going to go up 2 units, and I'm going to go to the right of 5 units. So I'm going to go up 2 units, that's my rise, and I'm going to go 5 units to the right, that's my run, which gives me my new coordinate point right here. And if we plotted that point is 1, 2, 3, 4, 5 units to the right. And this point right here is, we went up 4 units. So my new point is 5, 4. Now that I have my new point created by my rise over run and my y-intercepts, I'm going to go ahead and create my new line. So your graph should look something like this. Alright, for example 2, I want to graph the linear equation of y equals negative 3x minus 1. So this equation is in slope-intercept form, and slope-intercept form tells us two things. It tells us my slope and my y-intercept. So my slope right here is going to be the coefficient in front of x. So my slope is going to be m equals negative 3. So negative 3, remember that all whole numbers have a denominator of 1. So my slope is actually going to be negative 3 over 1. And my b value is going to be negative 1. So my slope is going to be negative 3 over 1. And my b value is negative 1. So this tells us that my y-intercept is going to be in the form of 0, comma b. So if my b value is negative 1, my y-intercept is going to be 0, comma negative 1. We have our slope, we have our y-intercept, and now we're going to graph our linear equation on our coordinate plane. So my y-intercept is 0, comma negative 1, so we're starting at the origin and going down 1 unit. So my y-intercept is at 0, comma negative 1. That is my y-intercept. And my slope tells me that I'm going to go 3 units down. 1, 2, 3 units down. And I'm going to go 1 unit to the right. Now that I have my y-intercept and my newly created points, I'm going to go ahead and connect the coordinate points, forming my graph. My graph has a negative slope. It's going down from left to right, and this makes sense because right here, if you look at our slope, it is negative 3, which is negative, so we have a negative slope. All right, for example 3, we want to graph the linear equation. So we have y equals negative x plus 5. It is in slope-intercept form, so we want to find the slope and the y-intercept by finding m and b. So right away here, we want to find our m. I'm going to take a look at the coefficients of x. It's negative. Now remember, in math, there's these things called invisible math. We don't see the coefficient here with negative x, but the coefficient is actually 1, but we just never write it. So the slope is going to be negative 1. All whole numbers have a denominator of 1, so the slope is actually going to be negative 1 over 1. My b value is going to be 5. Y-intercept is going to be in the form of 0, comma b because I have a linear equation in slope-intercept form. My y-intercept is going to be 0, comma 5. So now that I have my slope and I have my y-intercept, I'm going to go ahead and plot the following points on the coordinate plane. My y-intercept is going to be 0, comma 5, so I'm starting off at the origin and going up 5 units. 1, 2, 3, 4, 5. At 0, comma 5, I have my y-intercept. Now my slope tells me that I'm going to go down 1 unit and 1 unit to the right. So now I have my newly created points. Now that I have both of these points plotted, I'm going to go ahead and connect these 2 coordinate points, and they form my line of y equals negative x plus 5.